Yes, in this video we will continue to discuss how to delete from the RedBlack tree. I said at the beginning that the last principle in the RedBlack tree is that the coefficients of the black nodes that face each other on the path from the location of the rim to all the rim nodes should be the same. When this principle is ignored, we usually add what is called an extra black node. Solve this. To summarize, a node has been deleted from the RedBlack tree, and since the principle has been violated, we need to add an extra black node. Where do we add this? A node that replaces the location of the deleted book, adding it to that location. Yeah, it's hard to just talk. Let me listen to this poem. Let's say we delete the leftmost node 10 in the picture on the left. The color is black node, and the number of meaningful children is connected, and then the black node that is now 10, its own color, gets deleted. Well then, the principle is violated at this point, because based on the root node of 35, everything goes through the rif node once, but if you look to the left, you go to the 20 black nodes on the left. There are 30 black nodes on the right, so the number of black nodes passing through is 1, but none on the left. Okay, so this position is now a violation. So, when we delete 22 black nodes, and when we delete 12 black nodes, we add renode black nodes to ensure that we adhere to the principle that all leaf nodes are black. First of all, the moment we deleted the 20 black node, the principle was violated, so we added it to the additional day node and added an extra star black node to this location. As a result, there are 2 black nodes, and we call these cases double black. Now, there is the opposite case. Well, there is also a case where X star black is added to the red node. But here you can see that what is now called double black has happened. Let me look at the next example. Now, let's delete the node 30 in the picture on the left. Now, if it is a black node, the number of children is 1 red node with 25 on the left. Then the deleted node is the deleted color itself. In other words, the color black on the black road of 30 is now deleted, if you look at that picture on the right. At this position, the 25 red nodes that were at the bottom will now be replaced and brought up. Now it seems that the principle that we have to go through the same number of black nodes is violated here. So based on this root node of 35, the route to the leftmost 10 and then the route to 25 is different from the number of black nodes now. So we're going to add this extra black to this 25 red node position. So that's going to be the red plus extra black that we just showed you, and we can actually solve this problem by simply changing this red plus extra black into blanc dot. Let me look at the last example. Now let's delete the 50 red node. The number of meaningful child nodes is 40 and 80. This means that the color that actually gets deleted is the red node itself, which is 50, but the western synode. Successor is the leftmost part of the right subtree. This is going to be a node of 80. In other words, I want to delete the red node that is 50 now, but the color of the node that is actually deleted is the node that is 80, that is. The black color is removed. So if you look at the picture on the right, it's actually going up to the location where this 50 node was. You can see that the color doesn't change. The color is now red, only the color of the black node 80 that was at the bottom right is deleted, and only that value is raised, and now the red node 80 is created. Now, similarly, based on the root node of 35, you go to 80 on the right and then go to 40 on the left. Then, the position that was 82 on this standard will be replaced by this renode. For now, if you look at it without considering the renode, the number of black nodes passing through is different. The left is 10 dog, except 35 on the right. So similarly to this location that is now being deleted. We proceed based on the principle of adding renode plus extra black to create double black. To summarize, if we violate the principle that when we delete the color of the node, when we delete the node from the RedBlack, the number of black nodes passing from any node to all leaf nodes must be the same. We add extra black like this. And the position where this extra black is added can be said to be a load that replaces the 3 deleted positions. Now if you look at the load that replaced the 3 deleted positions again, if you look here we deleted 50, and the color that was actually deleted was black. And the position where that black is 80. That is. The position where I add extra black now is not 52, which I wanted to delete in the first place, but 80, the position of the actually deleted color, and add extra black to the position of the node. Yes, that's all about extra black. Next, let's take a look at how to actually balance extra black when it comes to this.